Hello there, guys, and welcome to our next class for the third unit. Teacher Krishna here, and just like you know, this is a class that is part of the high school and 11th high school. Our subject is Physics 2, and we're working on week number 25 today. So let's go over our presentation. Remember to have your notebook with you in order to make today's summary. And these are the parts that you need to include in your summary. Number 1, the date. Number 2, ending mind. Number 3, the title. Number 4, the summary itself. And of course, number 5, some additional decoration to it. All right. Let's go over our ending mind as well, which is explain the advantages of using digital transmission and storage, and to learn how waves are used in various technologies to storage energy or transmit and capture information. All right. Well, let me go with a summary of the activities that you need to do today. First of all, watch this video and make a summary. Number 2, read topic 6.07b and complement your summary. Number 3, go to page number 3, open the question panel, copy the questions in your notebook and answer them. Today, you are not going to have enough time before the live session, but make sure to do it afterwards, all right? And this is something very important. Number 4, participate in the Zoom meeting and make a summary of the content that was discussed. Join the meeting at 12:25. So just to let you know, today we're going to have a special guest during our live meeting. And he is one of the founders of telecommunications in Guatemala. So I'm pretty sure that you're going to find in this meeting that we're going to have pretty helpful for understanding the topic, as well as very enriching for your understanding and learning as well. So make sure you are on time today. It's very important that you're on time with cameras on and everything set up to be part of the conference, okay? So, yeah, that'll be about it. And let's start with a small introduction on the topic. So, today we're going to study telecommunications and digital information. And what is this strange artifact that you can see right here? Let's go over our content. So, communication, storage, and transport were way more difficult in the past. Letters were written and transported by horse. It will take the mailman the whole night to get to their destination. So technology has appeared in quite a few years, you know. So before, we didn't have that technology to communicate from one place to another in an instant like we do with cell phones right now. So communication was way less safe, because imagine that mailmen were traveling the whole night from one place to another. They were in danger of being robbed or something else happening. By 1838, telegraphs were invented. They would send messages, or codes, through special electrical lines that were read in special stations. It was not possible to store the message. So what you can see right here is a telegraph. So pretty much the industries that created the telegraphs had a certain language, let's say. So people will start pressing, and depending on how many times they will press the button in a certain sequence, it will mean a certain word. And of course, there were cables that were connected among these telegraphs. And there were people that were constantly monitoring the messages that were coming into the telegraphs. And they really had to pay attention to it, because there was not a device that could actually save the message that they were sending. Pretty much they just have to read it, then write it down by themselves, and that'll be about it. Then in 1910, radiotelegraphy was invented. So it was possible to send radio waves, and this type of communication is called analog. So instead of having like real and electrical cables connected among devices, we will start sending messages through radio waves, which was astonishing and amazing for everyone around the world. All right, and now let's talk a little bit about analog transmission. The information travels in the form of waves. It changes in frequencies depending on how much information is sent. And it's something very important. The higher the wave frequency is, the more information it carries. and the less distance it can travel. So yeah, pretty much like the smaller the wavelength is, then the more information it will carry. But we are not able to send that information for long distances. There are several advantages for analog transmission. Waves are constant, they are flexible as well, so they can change depending on what message we want to send. A small range of frequencies are needed to communicate. All right, now let's go with some of the disadvantages, and pretty much it is very expensive. So you need to set the transmitters as well as receivers in order to be able to communicate. And they are susceptible to destructive wave interference. All right. So here's one example. So when you are talking to someone on the phone, basically you are communicating through waves. So basically the voice or the sounds that you are producing are changed into waves, then they travel to an antenna that later on is going to transmit those waves to someone else that has another phone as well. So that's pretty much the way it works. Now we have radio wave interference. And this is extremely related to some of our local radios, such as Emisoras Unidas or FM, La Evolución de la Radio. And how are these related? So electromagnetic waves and radio waves travel in all directions. And they need to be focused to perceive their message. And the receiver antenna can still perceive unwanted signals. So if you have an antenna with you and you're reading the signals, probably you're trying to code a specific frequency, but you can still get some frequencies that are unwanted. So this is something very ironic because let's talk about Arnold Penzias and Robert Woodrow. They won the Nobel Prize in Physics in 1978. But how did they win the Nobel Prize? So basically, they were working with a radio antenna. And they were trying to code a signal that was unwanted at some point because they were trying to receive the waves from another antenna, but they didn't manage to do it because these other waves were interfering with their job. So once they started to code it, they noticed that the waves that were produced actually were not produced on Earth, but they were coming from outer space. So they started to analyze it. And something weird about these waves was that no matter in what direction they will focus their antenna to, they will still perceive the same radio waves. And these waves also were coded as the same, as with the same temperature. So basically, after constructing this information and after analyzing it, they came up with some evidence about the expansion of the universe. So they were saying that no matter in what way they would focus their radio waves, they will notice that the waves that they were perceiving were behaving in exactly the same way. And of course, it can be interpreted as the universe is expanding in all directions. So that's what actually got them to earn the Nobel Prize in Physics in 1978. So they were perceiving some unwanted signals, but imagine how ironic was that. All right, so in order to avoid interference, radio waves cannot be produced at the same time in frequency. So when we talk about frequency, for example, if you want to listen to Emisoras Unidas in Quetzaltenango, then your frequency in the radio must be 91.1. But if you want to listen to FM, La Evolución de la Radio, then you need to go to the frequency 95.5. Because what happens if, let's say that Emisoras Unidas is using the same frequency as FM. Then what happens is that you are not going to be able to listen to a clear sound coming from them. Because the waves that are produced are going to start interfering within each other. That is why frequencies are very important. And now we have analog versus digital communication. In 1950, information started to change from analog to digital. And made information to get up to global range without data loss due to interference. And something very important, what do we mean when we say digital? So information is changed to ones and zeros and sent as electrical pulses. So, for example, the presentation that you're seeing right now, and actually the video that is being recorded, basically are just zeros and ones that after going through different software in computers, the computer is going to decode this information as the presentation that you're watching and as the video we have right now. So it's interesting how the language of computers work, only zeros and ones. And advantages. It is less expensive, it produces less noise and interference. And increased capacity for information and travels through electrical pulses. Then we have the disadvantages. Interpretations errors between the transmitters can happen sometimes. It requires a greater range of frequencies, and perfect synchronization is needed as well. All right, so let's continue. And in terms of waves, how will the waves will actually look like whenever we talk about analog and digital? So the waves that you can see right at the top are an example of analog waves. And just like you can notice, they have like a more curved direction, right? But when we talk about the digital information, the waves or the information is a little bit more linear or straight, let's say. So that's why you can see that they remind us of the shapes of squares, rectangles, and straight lines in general. And they are different, of course, when we analyze them. Okay, now we have analog and digital signals work together. Analog signals create a wireless connection between several devices and antennas. Just like I was mentioning, like from a phone to an antenna, and from that same antenna to another phone. Analog signals send information that was once digital. So of course, remember that digital information are just zeros and one, but that information can be sent through analog signal. Now, please watch the video from page number 2. And of course, make a small analysis on what they tell you about. It is related to what I was telling you before, about the radio frequencies and some waves that can be perceived that are coming from space. So go ahead, once you are done watching that video, which is pretty short, you can come back to the video and we can continue. Alright, so welcome back. And lastly we have photoelectric technologies. And a solar panel is an example of photoelectric technologies. So Max Planck discovered energy could have wave-like and particle-like properties. And Albert Einstein agreed in other energy travels through quanta. And what is quantum? They are like discrete packets of energy. He also mentioned photon, which is a quantum of electromagnetic energy that usually describes energy that is emitted from the sun. We also have photoelectric technologies, which gather photons and change them into electrical energy. So a solar panel is an example of photoelectric technologies. And what is the photoelectric effect? It is energy that gathers that later on is going to release electrons and which generates an electrical current. One more time related to solar panels, in which they perceive sunlight, then the energy they have gathered inside is going to start exchanging and actually freeing some electrons. And of course, that motion of electrons inside the panel creates the electric current. Alright, so that'll be it for today's session, guys. I have great expectations from today's conference. So make sure to join on time at 12:25. Alright, so we can start up on time and you can have way more enriching information about this topic. It's been great to see you around. Always take care of yourselves and goodbye.